Okay, so we're going to be on page 22 today, and we're going to be talking about more about light and what it has to do with atoms and electrons. So the first thing you want to know is that all elements, when you heat them up enough and give them enough energy, they're going to give off light. So, like for example, a light bulb has a thin wire made of tungsten in it, and when that wire is given energy, it gives off this nice warm glow. Okay, now every element, the pattern of light that it gives off is called its atomic spectrum. So you guys remember, you've probably learned before, that when you pass light through a prism, you can separate it out into a rainbow, right? So the light from an element, like from the tungsten in this light bulb, it can be separated out too, but it's not going to be a full rainbow. It's going to be a set of lines, kind of like this. And that is called an atomic spectrum, or an atomic emission spectrum. To emit means to give off. So atoms emit light or give off light when they're heated. So we're going to write down the definition for atomic spectrum. So it is the pattern of light given off when an element is energized. Okay, and every single element is going to have a different pattern. So that pattern can help us identify the element. So it's kind of like a fingerprint for the element. Okay, so I don't know exactly what element this spectrum represents. It could be something like neon, but it's going to be different from every other element. Now you remember in the flame test lab last time, we put elements in a flame and they gave off different colors of light. That's what is going on in the flame test lab. The elements are getting heated up. They're giving off different colors of light because they all have different atomic emission spectra. So here is the hydrogen spectrum. When you heat up hydrogen, it looks pink. And if you split that pink light into its different colors, you see these just 5 lines, purple and blue and light blue and red. Our eyes interpret those all as pink. And in class, I heated up some hydrogen and we saw that it was pink. And then we had these cool glasses you can put on, and they separate out the pink light into those lines. So people actually got to see those lines in class. So how can we use this? Well, it's useful if we want to know, for example, what elements are in a star. We can look at the light coming back from that star and figure out what elements are in it. Okay, so I'm going to show you a question like one that you might encounter on a quiz or test in this section. So this says element X, Y, and Z produce the following spectra. So we have a spectrum for element X, element Y, and element Z. And then the question says, light from a star is found to produce the spectrum below. Which of the 3 elements does the star contain? So if you look at this spectrum, the one that it matches is element X, right? Because the lines are all the same. They line up with element X. So we would know the light from that star has element X. And who knows what element X is? Maybe it's lithium, maybe it's helium. Okay. Oh, and I'm showing you a lot of pictures this time. Here are the different spectra of different elements. So like mercury is Hg. Its spectrum looks like this. Lithium's looks like this. You can see sodium. Remember how sodium burns orange? It's just got one like light orange line down there, which makes sense because when you heat sodium up, it looks orange. Okay. So we want to understand how this light is emitted. So to understand that, we need to understand energy levels. So if we look at a picture of the atom, like this one, the orbits or circles around the nucleus where the electrons can be, those are called energy levels. And there's several different ones for each atom. So we're going to write down what energy levels are. So energy levels are possible orbits an electron can occupy. Okay, now these energy levels are something that we call quantized. So you've probably heard of like quantum physics. It's like a really fancy sounding science word, but it has a simple definition. If something is quantized, it means only certain levels are allowed. So let me give you an example of something that is quantized. So the common example that we give for things that are quantized is a ladder. So if I'm standing on this ladder, I could be standing on rung 1 or 2, but can I be hovering between rungs 1 and 2? No, not according to the laws of physics. That's impossible. So the ladder is quantized. I can be either on rung 1 or 2, but I can't be in between them. Okay, so like these stairs are quantized. You can be either on stair 1 or 2 or 3, but not in between them. But a ramp is not quantized because like I can be anywhere on this ramp. There's no levels. It's not divided into specific levels. So the atom, so this picture of the atom that we had, if I can find it, the energy levels in the atom are quantized. You can either be on the first one or the second one, but the electron cannot be in between them. It has to be either on the first or the second one. So in our notes now, we're going to draw a little picture of an atom. And we're going to draw 3 energy levels around the nucleus. So there are specific names for these quantized energy levels. So the closest circle to the nucleus is called the ground state. And electrons that are in the ground state have a low amount of energy. It's like, you can kind of think of it that it's like relaxing to be down there. Doesn't take much energy. They're happy in the ground state. So if an electron is there, it's not having very much energy. Now, if electrons get more energy, they can jump up to these excited states. So if electrons are in these, so if we have an atom with 1 electron and it jumps up to these energy levels, those are called excited states. And they have higher energy. Okay, so what does this all have to do with light, all of this energy level stuff? Well, if we have an atom and it's just got 1 electron, and that electron is in the ground state, if we give it energy, so if we hit it with some light or some heat, it can jump up to an excited state, and then it will want to fall back down. When it falls back down, it's going to give off light, and that's how the light is produced. When we put those elements in the flame, the electrons were getting energy, going up to an excited state, and then falling back down to ground state. Okay, so we've got a couple of more vocabulary words to write down, but we're almost done. So, you want to understand that, first of all, we have something called a photon. So a photon is a piece of light. It's like a particle of light. So it turns out light actually has some sort of particle-like properties. So a photon is a piece of light, and if an electron in an atom absorbs a photon, so when an electron absorbs a photon, it moves from its ground state to its excited state. So it's going to go from here to here. So if we zap the atom with electricity or heat or light, we put it in a flame, we zap it with electricity, this little electron, he's going to jump up to one of these levels because he has more energy. But electrons do not like to be in high energy states. Just like in general, things in nature like to be in low energy states. So that electron is going to fall. The electron will then fall from excited to ground state and emit, which means to give off, a photon. Okay, so you need to understand this process. Again, let me explain it one more time. Let me draw another electron as I do this. So let's say we have an electron right here. It's in ground state. Let's say some light comes in, hits that electron. It goes up to excited state. Now it's got a lot of energy, but it doesn't like being up there. It wants to get rid of that energy. So it's going to fall back down to ground state. But when it does that, it's going to give off some of that energy in the form of a photon of light. Now, that light could be different colors depending on the distance that the electron falls. So if it falls a long distance, it's giving off a lot of energy, so it would give off higher energy light, so maybe like purple light. But if it falls just a short distance, so maybe like from here to here, it would give off lower energy light, so maybe like red light. Okay, now the electron itself does not change colors. People sometimes get that confused. The photon that it gives off is colored. So it gives off colored light, but the electron itself doesn't change color. All right, this is some pretty abstract stuff. It's not stuff that you can actually see. So if you have questions about it, let me know. Please ask questions. I'm happy to answer them. But hopefully you now understand how elements can give off light. Again, this is what is going on in your light bulb. Let's go back to the picture of the light bulb. Tungsten, we're zapping it with electricity, so all of the electrons in there are getting a lot of energy, jumping up to excited state, and then they're falling back down and giving off a lot of different colors of light because there's a lot of different energy levels in tungsten. And our eyes see that light as white.